Assalamu alaikum. Today we are going to attempt October-November 2024 paper 4-2 mechanics. Code is 9709. In our first question, it says the velocity of a particle moving in a straight line at time t seconds after leaving a fixed point O is v meter per second. The diagram shows a velocity time graph which models the motion of particle from t equals 0 to t equals capital T. Graph consists of 4 straight line segments. The particle accelerates from rest to a speed of v meter per second over a period of 4 seconds and then decelerates at 5 over 3 meter per second square to instantaneous rest over a period of 6 seconds. The particle then travels back towards O, reaching a maximum speed of 3 meter per second before coming to rest at time t is equal to capital T. In part A, find the value of v. Alright, actually we can use a very simple formula for deceleration. D is equal to y over x. Instead of using physics formula, this is a mathematical simple formula. So our deceleration is 5 over 3 given equals our y is v and our x is 6. So cross multiply, make v the subject. So v equals 10 meter per second. This is a very simple way to handle this part. In part B, given that the total distance traveled by particle from t equals 0 to t equals capital T is 68 meter, find the value of t. So here we have two triangles and area under the graph is always distance in velocity time graph. So I use the first part 1 over 2 into base into height plus the second part is again our triangle which is 1 over 2 into base into height, and this all is equal to 68 meter which is given in the question. So now place the values. 1 over 2 into base is, in our first triangle our base is 10 and our height is the velocity which is we have already found out in the previous part, that is 10 also, plus 1 over 2 into, in the second triangle which is below the x-axis, our base is t minus 10. You can see from the diagram the capital T minus 10 is our base into, and our height is 3. You can see 3 which is written below the x-axis, and that is equal to 68. So this part is 50 plus multiply 3 inside the bracket, 3t minus 30 divided by 2 equals 68, and make t the subject from here. So your t is 22 meters. Question number 2. A block of mass 20 kg is held at rest at the top of a plane inclined at 30 degrees to the horizontal. The block is projected with speed 5 meter per second down a line of greatest slope of the plane. There is a resistance force acting on the block. As the block moves 2 meters down the plane from its point of projection, the work done against this resistance force is 50 joules. Find the speed of block when it has moved 2 meters down the plane. So if we make a simple diagram, our block is here and this is our height, and say this is 2 meter distance. Block reaches the floor, or you can say down the slope, and 30 meter angle is given, 30 degree angle is given. So from here I can say that sine of 30 degree equals opposite, which is h, over hypotenuse, which is 2. So in this way we can find out our height, which is 1 meter. So I'm going to use work energy principle, which is work done by driving force minus work done by resistance and this is equal to change in mechanical energy. Okay, work done by driving force is 0 because we don't have to use anything, or you can say we don't have any force to slide it down. So minus work done by resistance is 50 joules. This is change in mechanical energy, which is actually final kinetic energy minus initial. So our final kinetic energy is 1 over 2 half mv square actually. So 1 over 2 times mass is 20 and v square is v square minus the initial. Initial is actually kinetic energy plus potential energy. So we can place the values like 1 over 2 into half mv square, so 20, and initial was 5 velocity plus potential energy mgh, so m is 20, g is 10, and h is over 1, which we just found out with the help of sine 30 degree. So this is minus 50 equals 10v square minus 250 plus 200. So from here v square equals 40 and our v is square root of 40, which is 6.32 meter per second. Question number 3. A cyclist is riding along a straight horizontal road. The total mass of the cyclist and his bicycle is 90 kg. Power exerted by the cyclist is 250 watt. At an instant when the cyclist's speed is 5 meter per second, his acceleration is 0.1 meter per second square. In part A, find the value of the constant resistance to motion acting on the cyclist. So suppose this is the road and here is our cyclist. So this is our driving force and opposite is our resistance. So use the formula of power equals force into velocity. So from here make force the subject, so P over V. So our P is 250 and our velocity is 5. So this gives us 50. Now use F is equal to ma. So our F is driving force minus resistance is equal to ma. So driving force is 50 minus resistance equals mass is 90 and A is given 0.1. So from here over R is 41 Newton. The cyclist comes to the bottom of a hill inclined at 2 degrees to the horizontal. B part says, given that the power and resistance to motion are unchanged, find the steady speed which the cyclist could maintain when riding up the hill. So we can make a diagram. So this is 2 degree given here. So suppose from here this is our driving force, and in the opposite direction is our weight is mg sine 2 degree. Remember, always along the line of slope we use sine theta, and 41 is our resistance, which we found out in the previous part. And acceleration is 0 here because it has a constant speed. So again use F equals ma. So our F is driving force minus mg sine 2 degree, which is 90, g is 10, and sine of 2, minus 41, the resistance force, is equal to ma. Mass is mg, so 90 into 10, and our acceleration is 0. So this part becomes 0. So make df the subject. So it becomes 900 sine 2 degrees plus 41. So I'm going to use power equals d into v. So v equals p over d. So power is 250, and our d is 900 sine 2 degree plus 41. So this gives us the velocity 3.45 meter per second. In question number 4, the diagram shows two particles A and B of masses 0.2 kg and 0.1 kg respectively. The particles are suspended below a horizontal ceiling by two strings AP and BQ attached to a fixed point P and Q on the ceiling. The particles are connected by a horizontal string AB. Angle APQ equals 45 degree and BQP equals theta degree. Each string is light and inextensible. The particles are in equilibrium. Find the value of the tension in the string AB. So first we should make a drawing. This way our tension of particle A. This way our tension of particle B. So here is also tension of particle B, and this is tension of particle A. If I extend the line parallel to PQ, my theta comes here, and if I extend the line here parallel to PQ, my 45 degree comes here due to alternate angles. So in this way I can write T cos 45, and in this way I can write T cos theta. So my weight is 0.1 g here downwards, and here my weight is 0.2 g. So vertically I can write T sine 45 here, and vertically I can write here T sine theta. I think I have written all the forces on the diagram. Now let's solve them. Consider particle A. So if I solve forces vertically, so I can write T sine 45 degrees is equal to 0.2 g. You can see from the diagram T sine 45 here, this part, and the opposite is 0.2 g. So I equate them, and this is T times sine 45 is 1 over root 2 is equal to 0.2 times 10. So my T equals to root 2. If I solve particle A horizontally, I can write T equals T cos 45 this portion. So T equals, I just found out the value of T, which was 2 root 2, and cos 45 is again 1 over root 2. So root 2 gone, so my value of T is from here 2 Newton. Now I'm considering particle B. So if I solve vertical forces for B, can I write T sine theta equals 0.1 g? You can see from the diagram this portion, vertical forces, and it makes T sine theta equals 0.1 times 10. This gives us 1. So I can write T sine theta equals 1 as equation number 1. Now horizontal forces at B, they are T cos theta equals T. You can see in the diagram, this is T cos theta is equal to T. So T cos theta is equal to 2, because we found out the value of T is equal to 2 Newton, so make this equation number 2. Now equation 1 divided by equation 2. I can write T sine theta is equal to 1 divided by T cos theta is equal to 2. So T's are gone. Sine over cos makes tan. Tan theta is equal to 1 over 2. And theta is equal to tan inverse of 1 by 2, which gives us 26.56, or you can say 26.6 degrees. Put this value in equation 1. So T sine theta is equal to 1. So T is equal to 1 over sine theta. So T is equal to 1 over sine of 26.56, which gives us 2.24 Newton. This would be our answer for this part. In this part B, find the value of theta and the tension in the string BQ. So actually the value of theta we already found out in previous part as theta is equal to 26.6 degrees. So we can use this answer for part B also. But to find tension in BQ, let me show you the diagram. Tension in BQ. We can use Pythagoras theorem, and let me make a simple diagram for you here. Suppose this is our B, here is our tension BQ. So this is our theta here, and this was the tension in B, which we already found out as 2, and our weight was downward, which was 0.1 g, which is equal to 1. So if I extend this line and I make a right triangle, so my theta is here, and this is my 2, and this is my 1. So my hypotenuse is actually tension in BQ. So tension in BQ, I can write square of 2 plus square of 1 whole under root. So this is 2.236, which is approximately 2.24 Newton. Question number 5. Two particles P and Q of masses 2m, kg and mkg respectively are held at rest in the same vertical line. The heights of P and Q above horizontal ground are 1 meter and 2 meter respectively. P is projected vertically upwards with speed 2 meter per second. At the same instant, Q is released from rest. In part A, find the speed of each particle immediately before they collide. So if I make a diagram to make it understand, suppose this is our particle Q here. It moves some distance. So you can say distance of Q, and this is 1 meter. Here is our particle P, which when it collides with the Q, and the P was actually 1 meter below it. Actually this is our 1 meter, and from the ground the distance is also 1 meter. The total is 2 meters. So particle Q has been released downward, and you say this is the distance of P, particle P, and the initial velocity of P is given as 2 meters per second. So now let's find out distance of P. So I'm using S is equal to ut plus half gt square. So S is equal to, my initial velocity is 2 and my t is t, plus half my g is minus 10 because it's going upward, and t square. From here, when you simplify it, you get 2t minus 5t square. Now distance of q. Again use s is equal to ut plus half gt square. So s is equal to, my initial velocity is 0 for particle q, plus half, my g is 10 and my t is t square. After, when I simplify it, I get s equals 5t square. Now equate both distances because they meet at one point. So 1 meter plus distance of p is equal to 2 minus 1, or 2 minus distance of q so 1 plus distance of p, which we found out in terms of t, and that is 2t minus 5t square is equal to 2 minus distance of q is 5t square. So these two gone. From here 2t is equal to 1. This gives us time 0.5 seconds. Now use v is equal to u plus at, and this is for p, particle p. So v is equal to u, initial velocity of p was 2 plus minus 10, and t is 0.5, and this gives us minus 3. Minus 3 means p is moving downward. So therefore speed of p before collision is 3 meters per second. Now velocity of q, use again v is equal to u plus at. So initial velocity is 0 for q, a is 10 and t is 0.5. This gives us the velocity 5 meter per second, and this is the speed of q before collision. In part B, it is given that immediately after the collision, the downward speed of q is 3.5 meter per second. Find the speed of p at the instant that it reaches the ground. So now use principle of conservation of momentum. So mp up plus mq uq is equal to mp vp plus mq vp. Now put the values. Mass of p is 2m times initial velocity before collision was 3 meter per second, plus mass of q is m, initial velocity 5, and again 2m times vp plus m, mass of q, times 3.5. So these are cancelled. So 11 . equal to 2 Vp plus 3.5. So from here Vp equals 3.75. This is the speed of P after collision with Q. So when T is equal to 0.5 seconds, distance of Q five t square, and this gives us 5 into 0.5 square, and this is equal to 1.25 meters. Now distance of Q and P from ground on collision. Two minus 1.25. This is equal to 0.75 meters. So now use V square equals U square plus 2AS. So V square equals 3.75 square plus 2 into 10 into 0.75 and after simplification we get V equals 5.39 meter per second. This is the speed of P as it reaches the ground. Question number 6. A particle P travels in a straight line starting from a point O with velocity 6 meter per second. The acceleration of P at time t second after leaving O is a meter per second square, where a equals minus 1.5 t power 1 by 2 for t is less than equal to 1 greater than equal to 0, and a is 1.5 t power 1 over 2 minus 3 power t minus 1 over 2 for t is greater than 1. Find the velocity of P at t is equal to 1. So acceleration is given, so I have to integrate acceleration to get the velocity equation. So velocity equation is integration of acceleration, which is minus 1.5 t power 1 by 2 dt. So V equals minus 1.5 t power, you add 1 in 1 over 2, you get 3 by 2 over 3 by 2 plus c. So simplify it, you get V is equal to minus t power 3 by 2 plus c. So when t equals 0, our V is equal to 6. So you write 6 is equal to minus 0 power 3 by 2 plus c. So your c is equal to 6. So v is equal to minus t power 3 by 2 plus 6. Now when t is equal to 1, or v equals minus 1 power 3 by 2 plus 6. So velocity is 5 meter per second. In part B, given that there is no change in the velocity of p when t is equal to 1, find an expression for the velocity of p for t is greater than 1. So for t greater than 1, the expression is given a is equal to 1.5 t power 1 over 2 minus 3t power minus 1 over 2. So to get velocity again, we have to integrate this. So 1.5 t power 1 by 2 minus 3 t power minus 1 by 2 dt. So v equals 1.5 t power 3 by 2 over 3 by 2 minus 3t power 1 by 2 over 1 by 2 plus c. So after simplification we get v equals t power 3 by 2 minus 6t power 1 by 2 plus c. So when t is equal to 1 or v is 5, so 5 equals 1 power 3 by 2 minus 6, 1 power 1 by 2 plus c. So c is 10. So your equation is v equals t power 3 by 2 minus 6 t power 1 by 2 plus 10. In C part, given that the velocity of p is positive for t is less than or equal to 4, find the total distance traveled between t0 and t4. So area under the graph equals total distance traveled. So to get the distance, we have to integrate velocity. We are moving backwards. So s is equal to integral and limit from 0 to 1 minus t power 3 by 2 plus 6 dt plus integral from 1 to 4 t3 by 2 minus 6 t power 1 by 2 plus 10 dt. So integration gives us minus t power 5 by 2 over 5 by 2 plus 6t, and limits are 0 to 1 plus t power 5 by 2 over 5 by 2 minus 6 t power 3 by 2 over 3 by 2 plus 10t. Limits are from 1 to 4. So now simplifications. Minus 2 over 5 t power 5 by 2 plus 6t 0 to 1 plus 2 over 5 t power 5 by 2 minus 4t plus 10t, and limits are 1 to 4. Now upper limit minus lower limit. minus 2 over 5, upper limit is 1, 5 power 5 by 2 plus 6, in t I'm going to replace 1. This is upper limit minus, now lower limit is 0. So if you put 0 in t, this all will become 0, so no need to write it now. Close this bracket, plus now upper limit for and lower limit for the second part. 2 over 5, upper limit is 4, power 5 by 2 minus 4 into 4, power 3 by 2. I forgot to write 3 by 2 here, plus 10 into 4. This is my upper limit minus lower limit is 1, so you have to write 2 over 5, 1 power 5 by 2 minus 4 times 1 power 3 by 2 plus 10 into 1. So now after simplification I will get minus 2 over 5 plus 6 plus this is 2 over 5, 4 power 5 by 2 minus 4 into 4 power 3 by 2 plus 10 into 4 minus 2 over 5 minus 4 plus 10. So you get 28 over 5 plus 14.4. Finally, you get 20 meters answer. Question number 7. Two particles A and B of masses 0.2 kg and 0.3 kg respectively are attached to the ends of a light inextensible string. The string passes over a small fixed smooth pulley which is attached to the bottom of a rough plane inclined at an angle theta to the horizontal where sine theta is equal to 0.6. Particle A lies on the plane and particle B hangs vertically below the pulley 0.25 meter above horizontal ground. String between A and the pulley is parallel to the line of greatest slope of plane. Coefficient of friction between A and the plane is 1.125. Particle is released from rest. Find the tension in the string and magnitude of the acceleration of the particle. So if I start making the forces on the diagram, in this direction I have mu r. Here is my r, which is normal, and this is my 0.2 g cos theta. And in this direction, parallel to the slope, I can write 0.2 g sine of theta. Tension is here, and tension is here. Here is tension. This is 0.3 g. And now I'm going to use sine theta given as 0.6, so I can write sine theta equals 3 by 5. So I make a diagram, right triangle, theta is here, opposite over hypotenuse, so this is 4. So I can write cos theta equals 4 over 5. Mu is also given 1.125. Use forces at A. So F is equal to ma. The forces at A is 0.2 g sine theta plus T minus mu r, and that is equal to 0.2 ma. Here this side, if you see, so you make it equation number 1, and forces at B, again F equals ma, so 0.3 g minus T is equal to 0.3 a. Here forces at B. So make it equation number 2. Solve 1 and 2 simultaneously. So 0.3 g minus T equals 0.3 a, 0.2 g sine theta plus T minus mu r is equal to 0.2 a. So after these two are gone, so 3 plus 0.2 g is 10. Sine theta is 3 by 5 minus mu is given 1.125. R is over 0.2 times 10 times cos theta is 4 over 5, and this is equal to 0.3a plus 0.2a is 0.5a. Simplify whole of it. 3 plus 1.2 minus 1.8 is equal to 0.5a. A is 4.8 meter per second square. We can use 1 or 2 to find T, so I'm using equation 1. So 0.3 g minus T equals 0.3a. So 0.3 times 10 minus T equals 0.3 times 4.8. So our tension from here is 1.56 Newton. In part B, when B reaches the ground, it comes to rest. Find the total distance that A travels down the plane from when it is released until it comes to rest. You may assume that A does not reach the pulley. So if I make a simple diagram, this is our A. It reaches, when it reaches here, the distance is 0.25 meters. So the pulley slacks. So this way is mg sine theta, and this way is mu r, resistance. No tension in the string when B reaches the ground. Now speed of A, v square equals u square plus 2as. So v square equals 0 square plus 2 into A is 4.8, and distance is 0.25. So velocity is 1.55 meters per second. Now find acceleration of A when V reaches the ground. So use F is equal to ma. F is our mg sine theta minus mu r, you can see in the diagram, is equal to ma. So mg sine theta, so 0.2 times 10, sine theta is 3/5 minus 1.125, and r is over 0.2 times 10 mg cos theta, which is 4/5, is equal to ma. M is 0.2 and a is a. Simplify all of it, make a the subject, you will get minus 3 meter per second square. Now use v square equals u square plus 2as. So v is 0 and initial velocity become 1.55 square plus 2 negative 3, and the distance is s. From here s is equal to 0.4 meter. So the total distance of A before coming to rest is 0.25 plus 0.4 equals 0.65 meters. That would be our answer. Thank you.